Hi, everyone. Thank you for joining us this afternoon. My name is Caroline Griffin. I am Riot's Director of Operations. Very thankful to have you with us today. Before we get started, just a couple of quick reminders. If you have any questions throughout the event, please place those in the chat box. Aparna with Aurora Group is going to help me monitor that chat box. So we'll make sure all your questions are answered. Please make sure you have yourself on mute. We will give some time at the end. If you have additional questions, you'll be able to unmute yourself. But for now, please do mute yourself. And then last reminder, this presentation will be recorded and posted to Riot's YouTube channel and the meetup page to where you registered for this event. So you'll be able to find it afterwards. But without further ado, I know you guys are here to see the virtual lunch and learn session with Aurora Group and Taitien. So I will hand it over to Aparna. Thank you so much for being with us today.
Thank you for that kind introduction, Caroline. As Caroline mentioned, I'm with the Aurora Group and I represent a variety of electromechanical component manufacturers. Today, we're bringing you this lunch and learn session together with Taitien Platronics. Just a few words about the Aurora Group. Aurora Group is a firm that we've been representing and supporting manufacturers for over 30 years in the Southeast. Just a bit more about what we do. We offer and we are committed to facilitating technical component solutions for OEMs, CMs, engineers, and manufacturers. We offer technical advice on quality manufacturers. We guide through technical challenges with new and existing product solutions. And of course, we're the product liaison for quotes, ordering samples, and expediting. We touch on pretty much the full range of electromechanical components from magnetics to capacitors, electronics, as well as heat sinks, motion products, and motors. So pretty much any application you may be thinking of designing, we can support you with. Here's a quick view of our team. We have Bob Kirkland, myself, Ken, and Bob Ball in the Carolinas. We have Bruce covering Tennessee, Alabama, Mississippi, and Karen in Georgia. We also have pretty good coverage throughout the East Coast, and we are also connected with many trade groups. Here's a quick look at all the manufacturers we support. Here's also a quick look, including Riot, of the trade group association that we're a member of and participate with. And we also work with all the distributors. The main distributors for Platronics, Taitien, are also noted here as well. And now we are ready to introduce our speakers. So what really prompted us to have this lunch and learn was the recent TCXO shortage that's been going on in the industry. I think most people who are in the industry really understand this and want to have perhaps some potential alternatives is what we thought we'd present. We'll have Jordan Wohl presenting. He's a director of sales. He'll say a few words, and then the main man will be Kory, really talking about the high precision clocks for tight stability applications. And what I will be doing is monitoring the chat box. So if you have any questions, feel free to type them in there and I'll jump right in. Right now, I'm going to stop sharing my computer screen and hand it over to Kory and Jordan to continue.
Hello, everybody. My name is Jordan Wohl. I'm a director of sales for Taitien USA and Platronics. So servicing all of North America in terms of our customers, distributors, representatives like Aurora Group. Been with the company for 10 years. And so we've got a full line of frequency control products, everything from a basic crystal up to an oven oscillator. Like Aparna mentioned, the purpose of the meeting today is to kind of go over a solution that we have that should be of interest to certain manufacturers that are having a difficult time due to the TCXO shortage that we're experiencing currently because of the AKM factory with the unfortunate fire that they had in November in Japan. So with that, I'm going to pass over the mic to my colleague, Kory Stone, who is our Senior Technical Director of Sales. So Kory, I'll give it to you.
Great. And I appreciate that, Jordan, very much. And I appreciate Riot giving us the opportunity to present this. And we appreciate the fact that we've got a great quality sales representative in the Aurora Group. And this will be a relatively short presentation. The idea, as Jordan said, is to kind of just bring you up to speed on a situation we've got going on in the industry, and then the solution that we've got maybe that can help you out. So just kind of, we'll skip through the introduction real quick. We'll jump right to the problem. We'll talk about the options. We'll talk about the differences in our solution versus a TCXO solution. And then we'll talk about implementing our high precision clock oscillator in your TCXO application. So, I consider Taitien and Plantronics the best kept secret in North America. You probably haven't necessarily heard of us. Taitien, of course, is an Asian manufacturer headquartered in Taiwan with complete high volume manufacturing support. They purchased Plantronics a couple of years ago to give them a presence in North America. Plantronics has the North American location. We've got engineering support in Linwood, Washington. We specialize in fast delivery, small lot sizes, custom requirements. So between the two, Taitien and Plantronics were probably number 10, maybe number 9 in the world, depending on the day. We have the complete production capability, as Jordan said, from quartz to OCXOs, and complete in-house production capability. So that manufacturer is a big differentiator. There's a lot of guys in the crystal industry, but not everybody manufactures. And whenever you're talking about, quartz crystals, that manufacturing capability is a key issue. So, the reason why we're here is because there's been a major disruption in the supply chain for TCXOs, and TCXOs stands for temperature compensated crystal oscillator, which is a unique type of oscillator. And that means the ASIC device that they were using was relatively unique to TCXOs. Asahi Kasei Micro Devices, better known as AKM, suffered a fire in November of 2020, as Jordan indicated. They had and this was not a normal fire. They had 40 firefighters and 15 fire trucks pouring water on this fire for 3 days. And so, just an intense amount of heat pouring out of that. And the picture here is actually a picture of the foundry that burned up. You can kind of see the fire actually started on the upper 2 floors of the foundry, and you can kind of see the smoke damage there. And of course, that meant all the water and everything was pouring down onto the bottom 2 stories of the factory. And it's my understanding right now that that the building suffered structural damage, and that they're going to need to level that building and actually rebuild the foundry from ground up. And so the recovery is going to be, 9 months at best. Mostly probably going to be more like 12 months to 14 months until they actually start producing product out of the new foundry. And why this is critical is because TCXOs are used in most wireless devices. Every mobile phone you have probably has a couple of them. Your car probably has 8 or 9 of them. Your Bluetooth devices, your IoT devices, as you know, utilize TCXOs. And really it's because they were relatively low cost. They were very easy to get, and they did offer us some design margin. So, in that regard, it was a good choice. But unfortunately now TCXO lead time is 6 to 9 months. And so not necessarily a good choice. So what are our options? Your first option would be to go without TCXOs for 9 months, and I don't know anybody that really wants to do that. You can't bring yourself down like that. And the next option might be to try and build your own. You could go out and buy a crystal. You could go out and buy a transistor or another IC to form your oscillator circuit, but it's ultimately going to be bigger in size. It's going to be more power. It's going to be higher cost, and it's going to be lower reliability. So even building your own is not a good alternative. And so really the alternative we're really left with is to use a high precision clock oscillator where we're using TCXOs, because not all applications where we're using TCXOs require a TCXO. For example, we've got customers like Garmin and Amazon, and they've got Bluetooth applications, and Bluetooth is not a 2 part per million standard. Bluetooth is really a 20 part per million standard, and they were really just using the TCXO simply because it was already in their supply chain. But now, like I said, in their applications are finding that they're really looking at the high precision clock oscillator because they didn't need the accuracy of a TCXO, and they're not able to get it now. And we'll see that they're relatively close in size and cost. And so from a solution standpoint, I think it is a viable choice. So here's our options. The high precision clock oscillators, we call them the dash B types. For Taitien, it's the OZ-B, OX-B, OY-B. For Platronics, it's the QT22B, the QT33B, and the QT44B. It's relative to the package size. A lot of the TCXOs were common in the 2.0 by 1.6 package size, and we have that size available. 2.5 by 2.0 was a common size. 3.2 by 2.5 was a common size for CMOS TCXOs. So we've really got the size choices covered. We've got a wide frequency range. We can cover 1 to 200 megahertz. So that means we can cover the common frequencies that we're seeing in a lot of these applications: 20, 24, 26, 32, 40, 48. So we've got those almost on the shelf. And it does have a tight frequency stability. And this is really one of the big differentiators in the high precision clock oscillator, is because it is a clock. It does have temperature stability, 5 ppm minus 20 to plus 70, 12 ppm minus 30 to plus 85. So it's got a relatively good range and can operate over a range of supply voltages. So in general, where you've been using a TCXO, we got an option from a high precision clock oscillator standpoint. And what I wanted to do was run through the differences of the high stability, high precision clock oscillator and the TCXO. So we would, you'd be a better understanding about where those differences were. And of course, the biggest difference is the stability. We just get that in the name. Temperature compensated crystal oscillator means that the TCXO was compensated for errors in frequency that we would see. And over the life of the TCXO, a TCXO over a minus 30 to plus 85 is probably about 10 parts per million. Well, for our dash B type, we can get 10 part per million total, but maybe over a little bit more limited temperature range, 20 ppm over that same minus 30 to plus 85. But again, these are within the standards that we see for Wi-Fi or Bluetooth or LoRa or something like that. So, but I think it's also important for us to understand, what this means, because then we can, we're better able to use the part. And the fact that stability is actually calibration, or the tolerance at 25 degrees, the error, the temperature stability of the error with temperature, and then the aging of the part. The frequency will change over time. And here we've got a little bit more detailed look at the stability or the performance differences between the TCXO and the high precision clock oscillator. All crystals have a temperature error, and that's represented by the red line in this graph. And what we do in a temperature compensated crystal oscillator is we add a compensating voltage or varactor diode that adjusts the frequency of the crystal in an opposite direction that it wants to go for temperature. So the marry of the two is actually the green line that we see. So we take a crystal that might have plus and minus 20 parts per million worth of error, and through a varactor compensation, we're able to compensate it to plus and minus 2 parts per million. And so that's the temperature stability that we see here, the plus and minus 12 ppm of the red line going to the plus and minus 2 ppm of the temperature compensated oscillator. But you can see the calibration, or the tolerance at 25 degrees C, is the same between the TCXOs. The aging, or the stability of the oscillator over the life of your application, is the same, basically plus and minus 5 ppm. And so really we roll all these up to that total tolerance number, where a TCXO is about 8 to 10 part per million total over the life of operation, and a high precision clock oscillator is about 18 to 20 part per million over the life of your application. And your protocol will determine whether or not this error is going to be, acceptable to you. So that's the biggest thing you've got to understand, is that the high precision oscillator is going to have a slightly higher stability than what you see in your TCXO. But for the most part, I think you might be able to deal with that. There are other differences, and we'll look at those right now. And another big difference might be in the output type. A lot of TCXOs, particularly in the 2.0 by 1.6 millimeter package, or the 2.0 by 2.5 millimeter package, are clip sine wave output. And that's really done as much for power as anything. It allows us to get a low power oscillator circuit. The dash B type, or our high precision type, is an LV CMOS output. So it does have a little bit higher drive capability. And that shows up in the input power down at the bottom here. The TCXO is typically a 2 milliamp input power, and the dash B type is typically a 20 milliamp input power. And so, maybe not suitable for battery applications, but, certainly if you've got a, power source, something that can work. And the output phase noise is relatively close. The TCXO from an RMS phase jitter standpoint is about a half a picosecond, and the high precision clock oscillator dash B type is about a picosecond. So from a noise standpoint, they are relatively comparable. The high precision dash B type is a PLL output, and that's the phase noise plot that we see here. And it's that PLL that gives us that little bump in our noise and gives us that little rise. Beyond that, the next biggest issue to me is the pin connections, where if you've got a CMOS TCXO, it's almost a drop-in replacement. Pin 1 on the high precision clock is an output enable pin, whereas on a lot of TCXOs, the pin 1 function is either no connect or it's a ground function. So if it's no connect, it's really kind of a drop-in replacement. If it's ground, you'll see we've got to make an adjustment for that. And then if it's a clip sign TCXO, you'll see another difference would be the output type that we had talked about. The high precision clock is a CMOS, and the clip sign, the TCXO might be a clip sign. And so, if we understand these differences, then it can help us in our implementation. And that's what we're looking at here, is how would we implement a high precision dash B type to replace a CMOS TCXO in this case. And here we see the only difference that we have is that pin 1 connection with the output enable versus the pin 1 ground. And we just want to make sure that if we've grounded that pin 1 in our TCXO, we disconnect that ground. The output enable on the high precision clock oscillator is if the logic level on pin 1 is a high or floating, the oscillator is working. If the logic level on pin 1 is a ground or 0, then the oscillator is disabled. So if we have a ground on pin 1, we need to remove that ground to ensure that the oscillator is in the enable condition and producing an output for us. The next one gets a little bit trickier, and that's using the high precision dash B type to replace a clip sign TCXO. And here what we have to do is really convert the CMOS output to a level or an input level that's acceptable for our chipset, in the clip sign input. And here what we would do is we would simply add a conversion circuit. We would add a couple of diodes to drop the voltage. We would add a series resistor to limit the drive capability. And we would do all this before our DC cut capacitor. So we do it on, in a sense, the oscillator side of the cut capacitor versus the chipset side of the cut capacitor. Typically, the resistor that you're going to put in is about 100 ohms. But if your chipset is sensitive to high drive, then you may need to raise that to a kilo ohm. And the diodes are the diodes. They drop 0.7 volts. And so that means your clip sine wave output is going to be about 0.7 to 0.8 volts peak to peak, typical of the clip sign TCXO. So absolutely dropping this right in there. And again, you got to keep in mind that pin 1 thing. If the pin 1 of the TCXO is ground, you'll need to disconnect that ground to make sure that it's connecting. So I've kind of rolled through this relatively quickly, but, hopefully you saw that, there is a major disruption in the TCXO supply chain that you need to be aware of, that, you may be using a TCXO in an application that may not require it. And an enhanced stability clock like the dash B type could be a viable solution for you. So, get in touch with Aparna and the folks at Aurora, get in touch with Jordan or myself. Let's talk about your application. Let's talk about your implementation and come up with a solution for you, because we know you can't wait 9 months to start getting TCXOs back. And we did just get an update from AKM. And while they are, looking at plan B and that sort of thing, it really does look like it's going to be the fourth quarter until AKM starts shipping ICs to the industry again. There are other TCXO ICs out there, but AKM had 80 to 90% of the market for a good reason, and that was their performance. And so, you know, while these other chips are out there, they don't look like they're really viable solutions to replace the AKM IC. So again, the enhanceability clock is a good short-term solution. And actually, I almost look at it as a longer-term solution, because whenever the TCXOs come back, we know that they're going to be a higher price than what they left at. And we know that they're going to be in short supply initially, as, you know, the big players, the 800-pound gorillas in the market, you know, consume all that near-term demand. So I really think that you'll find that the enhanceability clock oscillator is a great solution to move forward with, even in production. So
Kory, can you, talk a little bit, go back a few slides and talk about some of the lead time differences for the two options.
Yeah. So, and I guess I'm not sure where you wanted me to go, but pardon?
The next slide.
This one or this one?
No, further down. That one. Yeah.
Okay.
So all the Taitien and Plantronics part numbers. What does that lead time look like?
Right now, you know, for samples, we're talking about, you know, 4 weeks, couple 4 weeks. For production quantities, we're talking about 6 to 8 weeks. So
these are available at distributors now.
That's correct. The initial stocking orders are in process. So I guess I'm not sure it's actually on the shelves now, but if not, they'll be there soon.
Okay. Does anybody from
that would be the DigiKeys, the Mausers, the you know, those types of guys.
So is anybody in the audience having design related questions? I haven't seen too many of those questions yet, but any design related questions is a great time to ask. Kory is very, very good at answering those.
Well, we do it with frequency, so you know, feel free.
Is there any other things that you can think of that people need to be aware of?
Well, I think that people, you know, I think this is an important slide for people to understand, because a lot of times whenever we talk about crystals and oscillators, we sometimes, like whenever we talk about clock oscillators, we tend to use a total tolerance type of number, because and so whenever we talk about high precision clock oscillators, we'll tend to talk about a 1-year total tolerance or a lifetime total tolerance of 20 part per million or 25 part per million, something like that. When we talk about TCXOs, we tend to cut, because the numbers are cut smaller, we tend to talk about them more individually. So whenever they talk about a 2 part per million TCXO, they're really only talking about the temperature stability. They're not talking about the calibration tolerance, and they're not talking about the aging rate. These would be things that generally are included in the clock number whenever we talk about them, but not in the TCXO number. So I think it's important that as you're looking at the products you're using and even talking about alternate products, that you understand, you know, the accuracies and the tolerances that you are using, and making a good comparison that way.
Can you talk a little bit about the power difference between the TCXO and the high precision -Bs?
Yeah, and you know, this is you know, the clip sign, of course, does give us a low power capability. The 20 milliamps max is really kind of the worst case number. Of course, if they have a low capacitive load on the output of the device, or their chipset has a low capacitive load, then the -B type isn't necessarily going to draw the full 20 milliamps. But so this is the input current of the -B type is somewhat related to the amount of output drive we're expecting from it. This is a worst case number, and so we would really expect it to be more closer to you know, 10 milliamps, which is, you know, maybe a 5x trade-off versus the 10x trade-off.
So what are some applications that absolutely you just have to stick with the TCXO?
So an application that you'd have to, stick with the TCXO might be a GPS type of application. You need to have a high accuracy device there. Lora, is my understanding, is a 50 part per million type of tolerance. So Lora would be a place that if you're using a TCXO, you could easily switch to a high precision clock. Bluetooth is probably the biggest application that we've seen where people are using TCXOs and they do not need the stability of the TCXO. That would be 26 megahertz. I think they're, again, just using the TCXO because of its availability. But now because because of the availability, before this incident happened, tight stability clocks were available, but they were only priced the same as a TCXO. So if you could get a 2 part per million part at the same price as a 20 part per million part, you would buy the 2 part per million part. But now we know coming back, TCXOs are going to be higher. We know right now you can't get TCXOs, and so the high precision -B type is a viable alternative to TCXOs, where you might have used it for cost and availability reasons before. The high precision -B type is the cost and availability solution right now.
Got it. Not seeing a whole lot of questions yet.
Well, that means the presentation was very good. Answered all the questions through the presentation. So yep. I doubt it was that good, but
well, one of the gentlemen said that hadn't heard of the shortage yet, as they're using prototypes for MCUs with oscillators, not precision timing. So they don't need that precision, in his application.
Yeah. Yeah, well, this is, I'll just give you, I'll call you an industry update. And I think lead times, 2020 was a difficult year for the frequency control industry. We have, there's a shortage of 32.768 kilohertz watch crystals. So the 32 kilohertz watch crystals, the lead time is still extended in terms of 4 to 6 months in terms of availability. We had the AKM fire, which interrupted, TCXO supply, and then we had of course, the pandemic situation, which affected our factories and our abilities to produce in the factory. So 2020 was a very difficult year. In response to that, though, I think, what is a normal lead time is no longer a normal lead time. So I would encourage everybody that's on the call, if you're a user of these types of products, just to go out and check your supply chain, check your lead times, because we know lead times are getting longer in the market. The people that weren't using the other guy, there were other guys that made TCXO ICs, but as everybody else starts to buy those chips, then those lead times will go out. And we know the foundries are getting full, with other types of chips. And so we see IC lead time in general moving out. The automotive industry is driving huge volumes. And so we see shortages in terms of packages. And so, we see our raw materials, ICs and packages moving out. The good news is we're a quartz manufacturer. We cut our own quartz, we dice our own quartz, we make our own crystals. And so we're in control of that particular portion of the part. And so, no worries there. But, if you look at an oscillator, it's 3 basic things. It's a crystal, it's a package, and it's an IC. The lead time and cost is moving up on 2 of those things, the package and the IC. We're controlling the cost on the crystal, but, it just kind of goes back to check your supply chain and make sure you understand what your lead times are, and, work with your suppliers so that they're taking care of you.
So Kory, we had a tough question here. Do other manufacturers offer equivalent to the -B type that we talked about?
So there are a few other manufacturers that offer an equivalent to the -B type. The real secret behind the -B type is, we're taking quartz and actually, one moment. We take a bar of quartz like this. Mm-hmm. Quartz is the second hardest material known to man, and we slice it down to thicknesses that are thinner than a sheet of paper. We work in thicknesses that are in the thousandths of an inch. A 20 megahertz crystal is about 3/1000ths of an inch thick. A sheet of paper is about 4/1000ths of an inch thick. So we're taking quartz, the second hardest material known to man. We're cutting it into wafers that are thinner than a sheet of paper. And the angle at which we cut it determines the temperature characteristic. So if I cut it at this angle, I get one temperature characteristic. If I cut it at this angle, I get a different temperature characteristic. And so the ability to make a -B type is your ability to control that angle. If you can't control that angle, you can't control that temperature characteristic, and so you can't control the tolerance of the part. And whenever we talk about angle control, we talk about, angles are divided up into degrees, degrees are divided up into minutes, and minutes are divided up into seconds. We talk about our angle control in terms of plus and minus 15 seconds worth of angle control in the way we cut that. Which results in about a couple of part per million variation in terms of the temperature curve, which is the reason why we can produce a -B type. And so the reason why I went through that for you was so you'd understand quartz and how we cut it and how we get to some of the things that we do, but it really takes a manufacturer to make a -B type, because you have to have control over your processes. And if you don't have control, you can't, in a sense, you can't buy it type of thing. You might be able to screen it, buy a part from somebody else and then screen it to a tighter level, but it takes a manufacturer to ensure the quality and ensure the tolerance. So yes, there are a few other people that do the -B type.
That was the short answer, Kory.
There you go. Yeah.
Take a very tough situation and break it down into a good alternative solution that could work in a lot of applications, except GPS related applications.
Yeah, that's the big one. GPS or RF might be another one that I would throw in there.
Okay. Well, we're a little bit light on the questions. Jordan, did you have anything you wanted to add?
I think Kory covered it fairly well, but I would just encourage everybody to kind of do a little bit of homework on this AKM situation. I saw a couple messages from folks who weren't aware of it, and I talked to actually a lot of our, kind of tier 2 and tier 3 customers that really haven't heard about it yet. Most of your large volume users know exactly what's going on, and they started back in like mid-November trying to come up with alternatives. So, but even if, let's say, you're using 1,000 to 5,000 pieces a year, there's going to be issues in sourcing that product. A lot of the customers are looking to other equivalent part numbers, or they're making concessions on the spec just to have something to use, maybe a narrower temp range or what have you. But it's one of those things that you want to get in front of the curve to make sure that you have supply of some sort coming in to your manufacturing.
Yeah. Jordan kind of reminded me of something as he was talking about that, and that's the temperature range. And the temperature range has a lot to do with the ultimate stability that we can achieve with the -B type. And you saw that we were talking about plus and minus 10 ppm over minus 20 to plus 70, but it goes to plus and minus 20 ppm over minus 30 to plus 70 degrees. So if you're able to work over a narrower temperature range, 0 to 60, 0 to 50, something like that, then we can actually beat these numbers and almost hit TCXO types of stability. So, if you're able to control your temperature range to a relatively narrow degree, then this becomes a phenomenal replacement for the TCXO in terms of stability. But, and that's all comes down to, if the three big sources of error in crystals is time, temperature, and calibration. That's, what we have here. If you can control the temperature, then you've done one thing to really just improve the stability of your oscillator. So,
hey, Kory, this is Bob Ball. You mentioned to us, I think last week, that as AKM comes back online, the crystals that are going to be put out, they're going to have different circuits in it. So most all customers are going to have to reevaluate or re-engineer. Can you address that?
Sure. So, you know, there's three ways that we see AKM coming back. And, you know, the first way is to take the existing ICs that they were building and have them fabbed outside. And so indeed they are doing that. They've taken their mask sets and they've provided them to an outside manufacturer, and they've manufactured or in the process of manufacturing some samples. So, you know, there will be a fab change at a minimum. You will be looking at a fab change, and whether that requires requalification in your activity or not, you know, for the major, you know, for the tier one guys, you know, like the Ciscos and those types of people, they'll probably end up requalifying it because of that fab change. I'm not sure that would be necessary. There probably will also be an IC change. I think we know that AKM is not coming back with all the ICs that they left with. They're going to be changing wafer size. They're going to be moving from a 6-inch wafer to an 8-inch wafer. And, you know, that automatically means that some of their mask sets are no longer usable. And if you're familiar with ICs, you know that IC mask sets cost multiple millions of dollars. And so, you know, they aren't going to tool up they aren't going to take the old ICs to the new the new wafer size. So we know that some of the old ICs will be going back. And so most probably you'll be looking at some level of requalification. If the IC that you were using was not the IC that they're bringing back, then you're going to be getting a different part. And you're going to have to look at requalification. And then third way is other manufacturers. We know that some suppliers are using, and us too, are looking at other IC suppliers, you know, that make TCXO ICs. There was a reason why they were a small volume in the marketplace. And it would be difficult for them to come back and replace, you know, any of the AKM stuff. And we are seeing performance differences between the other guys and AKM. And so, you know, a third choice would be to use a non-AKM IC, but there again, you're going to have to look at the differences in terms of noise and voltage stability, load stability, those types of things.
Well, thank you.
Okay, thank you.
So far, I don't see any other questions in the chat box. Again, I think you can probably go to the last slide, put your name and phone number at the bottom. This presentation will be sent out along to all the registrants by Riot. And if you have an urgent question regarding this, please feel free to reach out to us at the Aurora Group or Jordan or Kory directly. And really thank you for attending this meeting. And I will be turning it back over to Caroline if no one has any additional questions.
I'd just like to jump in. You know, the other thing that AKM made was D to A's and DACs for audio equipment. And so if you're looking at buying a TV soundbar for the Super Bowl or a TV for the Super Bowl, you might want to get your consumer audio equipment early.
It's a good to know. I'm keeping mine.
There you go. There you go.
So back to you, Caroline.
Sorry, Caroline.
Thank you so much, Aparna. No, that's a great advice, Kory, for sure. We do have a question that just came in actually from Robert. When will AKM chips built by another fab be available for your TCXOs?
We're talking about third quarter. So we're anticipating receiving our first samples of the new fabbed ICs at the end of the second quarter. If they're acceptable, it will take AKM another 16 weeks to start producing chips from there. So, you know, we're talking about probably, say early October for the next AKM product.
That's helpful. Thanks, Kory. Great question, Robert, as Aparna said. Well, we'll leave it open for just another minute for questions, but I encourage you to reach out to Jordan, Kory, also Aparna at the Aurora Group. Aurora Group's been a long-time supporter of Riot. We're thankful to have them in our sponsor ecosystem and really thankful to have the guys from Taitien here today. If no other questions come in, I hope everyone has a great day. Thanks for joining us. And as Aparna mentioned, you'll be able to find this on the meetup page and on Riot's YouTube channel. Thanks, everybody. Take care.
Thank
Thank you, everybody.
Thank you.
Have a good day.
Bye.